Hello everyone. This video is on section 10.5 part 2 titled Solving Exponential Equations. In this video I'm going to be going over a version of the Knewton Alta assignment for section 10.5 part 2. Now please understand that the questions you see in this video may not be the same questions you see when you work on the assignment yourself. But the objectives are the same, the types of questions should be similar, so I'm hoping that watching me do several of them here will help you in some way when you're working on the assignment on your own. Okay, so here's the assignment page. You will not see the words preview of, you'll just see the title of the assignment. You'll have the mastery bar telling you how far along you've gotten, and the objectives. And it looks as though there's only one objective in this particular assignment. Alright, then under the current objective there's a question related to that. And at the bottom of each question you should see a feedback button, which you can send feedback to Knewton if you wish. You will not see an instructor cheat button, right? This will not be there. But you will see a more instruction button, which if you click on this, you'll be provided with further reading material or videos related to the current objective. Alright, so this question, along with all the questions in this particular assignment, is related to the objective solve exponential equations using logarithms. So the key to this section here, the key to this assignment, is remembering how to go back and forth between exponential form and logarithmic form. Alright, so I'm going to write this equation out, and we're asked to solve for x. Right? You have 1/2 to the x power equals 6. We're asked to solve for x and round our solution to 3 decimal places, right, or to the nearest thousandth. Alright, so again, the key is, hopefully you remember this, right? I haven't written it in a little while, but going from exponential form, say b, if b to the x equals y, then that means, that's equivalent to saying x, right, the exponent, equals the logarithm of y with a base of b, right, the base on that exponent. So I'm hoping you recall this, right, the ability to transfer back and forth between exponential and logarithmic form, because that's going to be, again, key to solving these equations we're given. So notice that this equation starts off like this exponential form here. I've got some number to a power with a variable in it equal to another number, just like b to the x equals y. So I just simply change to, this is an exponential form, I change to logarithmic form. I'll just say log form. Right. So if 1/2 to the x is equal to 6, that means that x, right, the exponent, is equal to the log of 6 with a base of 1/2, right? Log base 1/2 of 6. Now I have a particular calculator, that you can actually just enter this the way it looks, right? I'll pull that up. I have a TI-84 Plus emulator. So here that is, right? And on the TI-84 Plus, if you hit the math button and scroll down, you'll see this log base, where you can enter any base you wish. This has a base of 1/2. So I put the base in there, and then the argument is 6. I'm taking the log base 1/2 of 6 and getting negative 2.5849. So that would be 585 if I round to the 3 decimal places. Alright, and this is what they want. Alright, this is what they want. Okay. And don't forget to check. All right, let's check this. Is 1/2 to the negative 2.585, is this about 6? All right, let's see. So I'll take 1/2, which is just 0.5, and raise it. Well, I'll just raise it to the previous answer, right? The negative 2.589499625. This should be 6, and it is. So that is a valid solution. Now, that's not the only way you could have found this, right? Very often, a calculator doesn't have log of whatever base you want button, or a log of whatever base you want feature. So another thing you're going to have to remember here, and this is from a previous section as well, is the change of base formula. All right. So if I want to take the log base 1/2 of 6, but I only have a calculator that has log base 10, right, log, or log base e, that natural log, ln. Say I only have those two buttons. Well, instead of taking the log base 1/2 of 6, we can take the log base 10 of 6, or the log base e, whatever one you want. Just change the base to 10 or to e, but then after that you have to divide by this new log of the original base. All right, so this is equivalent to the log of 6, log base 10 of 6 divided by the log base 10 of 1/2. Or you could have had ln of 6, natural log of 6, divided by ln of 1/2, same thing. And let me show you, right? I'll show you that that's equivalent, right? You should hopefully, I'm hoping you remember the change of base rule. All right, but if I go log of 6 divided by the log of 1/2, it should give me the same value, this negative 2.5849 stuff. Okay. And as I mentioned, you can change it to whatever base you want. I could do log base e of 6 and then divide by the log base e, the natural log of 1/2. Well, let's put 0.5. And it's the same value. All right, so it doesn't matter what base you change it to, you just got to stay consistent. Do log divided by log or ln divided by ln. All right, either way though, all right, either way you do this, the result rounds to your solution x being negative 2. Approximately negative 2.585. Right, so that's what I'm going to be entering here. Right, you see they have the little approximately equal to symbol. Negative 2.585 when rounded to 3 decimal places. Great. Right, and then after every question, right, you should see an answer explanation, whether you got it right or wrong. Please read through these. If you got it right, make sure you're reading through and just seeing that you got it right for the right reasons. All right, now they're doing it a different way. See, this is another thing that could benefit you when you're reading answer explanations. Perhaps they do it with an alternate method, and maybe you like the way they're doing it better, and you can use that method for future questions that are similar. Now, if you got it wrong, definitely read through the answer explanations and try to figure out what you could do to fix your mistakes in the future. Okay, next question. Same objective. We're asked to solve a particular exponential equation using logarithms and rounding our final answer, our final solution, to 3 decimal places, right, to the nearest thousandth. All right, so once again, this is something that's a nice exponential form, right? Just a number to a power with a variable equal to another number. So if I want to solve for that variable very, very quickly, I can just change to log form. Right, change to logarithmic form. I'll just say log form, and that would be x equals the log base 5 of 110. And there's our solution. Right, x is solved for, x is alone. So this number, whatever it is the answer. But they're having us round it. Right, the log base 5 of 110 is, approximately equal to, and I'll just enter this on my calculator. So I'm pulling my calculator up. Let's clear the old stuff. So again, I have a calculator where I can actually enter whatever base I want. Right? So I go log base 5 of 110, and the answer is approximately 2.9205, right? That's 5. The fourth decimal place is 5 or higher, so I'm bumping the third decimal place up 1 when I round. So x is approximately equal to 2.921. Now again, I could also have used the change of base. This log base 5 of 110 is the same as the log of 110 divided by the log of 5. And I'd get the same exact thing. And let me just double check, show you that here. The log of 110, do log base 10 of 110, and then divide by the same log of the original base, right, of 5, and you get the same value. Or I could have done natural log, I could have done that ln. Either way, the solution, right, the value of x here, ends up being 2.921 when rounded to 3 decimal places. And you can check it too by plugging it back in and seeing if the statement's true, but I feel like I'm doing everything right here. So back in the assignment, I've entered 2.921 in the slot. Great. All right, and once again, they're doing it a little differently than I am, but you might want to check that out, or but I personally like going from exponential form to logarithmic form. All right. Okay, next question. And I believe they're all like this. All right, yeah, absolutely. All right, so I'm just going to put this on the same page. We're asked to solve this equation and round our solution to 3 decimal places again. So we have 7 to the x power equals 114. This is in exponential form. If I change to log form, logarithmic form, that's x equals the log base 7 of 114, and x is solved for. There's the answer. Now this is approximately, and I'll go to the calculator. Right? And this time I'll just use the change of base straight away. Right. So if I want the log base 7 of 114, I can just take the log base 10 of 114 and then divide by the log base 10 of 7, right, the original base. And we're getting about 2.4339, so about 2.434, right, if I round to 3 decimal places. 2.434. And that is what I shall enter back in the assignment. All right, so x is approximately 2.434. Okay. And there should just be one more like this. All right, now this is a little different. All right, this is a little different because I'm not just solving for x. I'm sorry, I am solving for x, but notice that the exponent doesn't have just x in it. The exponent on e here is x plus 2. But the procedure doesn't change. All right, so let me show you this. So we have 2 times e to the x plus 2 power equals 32. All right, so this is not an exponential form just yet. I got to get the exponential expression alone first before I change to logarithmic form. So get the exponential expression alone. I'll just say get exponential alone to have it in exponential form. So that would require, you got the times 2 here. I don't like this. That would require dividing by 2. So I have e to the x plus 2 power equals, and then 32 divided by 2 is 16. All right, so now I'm in nice exponential form, and we're going to change to log form. Right, only after getting the base and exponent with the variable alone, like I have here. So I changed to log form. Now this time's a little different, because again, the exponent's not just x. This time it's x plus 2. But remember, the exponent, x plus 2, is a logarithm. And it would be the log base e of 16. Now don't forget, yeah, this is fine, log base e, but very often, instead of writing log base e, remember that's the natural log, that's ln of 16. Now notice that x is not solved for. Alright, x plus 2 is alone, but I want to solve for x. So now I'm just simply subtracting 2 from both sides. And we get x equals, whatever the natural log of 16 is, and then minus 2. Right, and there's our solution. Alright, so in these equations where there's a little more involved, first you got to get that base and exponent with the variable, get that exponential statement alone, nothing around it, and then change the logarithmic form and then solve for x. So it's just got one little extra step. Alright, then I'll punch this in my calculator, and we're asked to again round our solution here. This natural log of 16 minus 2, we're asked to round this to 3 decimal places. Alright, so calculator up. We have our solution is the natural log, ln, log base e, the natural log of 16, and then minus 2. And I'm getting, approximately 0.7725, right? So the fourth decimal place is 5 or more. So I'm going to bump the third decimal place up 1. So this is approximately 0.773 for the solution. Alright, and you can check it by plugging that back in for x in the equation and seeing with the calculator if that makes a true statement or not, but it should. And I'll show you, right? Look at the original equation. In the calculator, I'll go 2 times e to the previous answer plus 2 in the exponent. That's 2 times e to the x plus 2. And this should be 32. And it is. So it satisfies the original equation. Wonderful. All right. Great, so let's get this down, and I'm going to be entering 0.773 back in the assignment. 0.773. So yeah, get the exponential, the base and the variable power alone, then change to logarithmic form, solve for the variable. Right, those 3 steps every single time. Alright, great. See, isolate the exponential, first step they do. Alright, then of course read through the answer explanations, right, and just make sure you're learning from your mistakes. Alright, so this should be it for this version of this assignment, right, just one objective. As I said at the top of the video, right, the questions I saw here most likely won't be the same questions that you see when you work on the assignment, but the objective is the same, the types of questions you see will be similar, the way you do them would be similar. So I'm hoping that watching me go through these 4 here help you in some way when you're working on the assignment on your own. Thank you very much for watching.